Hello all. I'll be introducing us to inferential statistics. Inferential statistics involves making predictions or inference about the population based on a sample data. This branch of statistics helps to draw conclusions that go beyond the immediate data alone. So inferential statistics is perfect for making prediction in summary. So where do we apply inferential statistics? In market research, to predict consumer behavior or preference made on a sample survey, medical trials to determine the effectiveness of a new treatment or a new drug. It's perfect for quality control, social sciences, and the rest. This slide will be made available for you to read through, and its importance is that it's good for decision making. Remember, one of the sole aim for data analysis is that by the time we collect data, clean data, and then we analyze it, then we can effectively make decisions. So inferential statistics is one useful tool to aid decision making, informed decision making using sample data. It is good for generalization. So whatever findings you get from your sample data, you can apply it to a broader population, and it is useful for hypothesis testing to test theories or hypotheses about population parameters. Now, what are the components of inferential statistics? We have point estimates, for example, sample mean, and then we have confidence intervals, and then we also have hypothesis testing as one of the components of inferential statistics. Hypothesis testing involves testing an assumption about a population parameter, and it uses sample data to evaluate the validity of a hypothesis. Okay, so what then are the hypothesis tools and formulas? So the steps we follow in handling hypothesis testing is, first, we need to formulate hypothesis using the null hypothesis technique and the alternative hypothesis technique. The null hypothesis technique is that there is no effect or difference. It represents the status quo. For instance, male like blue, ladies like pink. That is a status quo. It's a generalized concept, but how true that is a null hypothesis. And then the alternative hypothesis represents the claim that has been tested or that is being tested. Okay, so then we have select significance level with a symbol alpha. This helps us to know when to reject or accept a null hypothesis when it is actually true. And the constant for this is 0.05. And then we then need to choose appropriate test statistics to determine our hypothesis. Some of these test statistics include t-test, z-test, ANOVA, and the rest. Now, to calculate the test statistics, we need to use sample data to compute the value of the test statistics. First off, we need to use sample data, and then by the time we use any of the test statistics technique, then we can be able to determine the p-value or the critical value. The p-value indicates the probability of obtaining the observed data if the null hypothesis is true or not. The critical value is a threshold that determines the rejection region. And then we can now make a decision by comparing the p-value with alpha or the test statistics with the critical value to decide whether to reject or fail to reject the null hypothesis. All right, so common test statistics are z-test, t-test, chi-square, and ANOVA, like I've said before. Z-test is best used when the population variance is known and the sample size is large. T-test is best used when the population variance is unknown and the sample size is small. Chi-square test is best used to test relationship between categorical variables, and ANOVA, known as analysis of variance, is used to compare means across 3 or more groups. T-test is 1 or 2 groups, ANOVA 3 or more groups. And then we have F, that is between group variability / within or group variability. All right. Then there are rules and considerations to this. First, be working with assumptions. Ensure that the assumption for each test are met, e.g. the normality, the independence, homogeneity of variance. Then for the p-value interpretation, a small p-value is typically less than or equal to 0.005, which indicates strong evidence against the null hypothesis. Strong evidence, so it is rejected. A large p-value is usually less greater than 0.05, indicating a weak evidence against the null hypothesis, so it is not rejected. All right, so when it is greater than 0.05, not rejected. And then we have type 1 and type 2 errors. We have the type 1 error for the alpha, which shows that we are incorrectly rejecting the null hypothesis when it is true. And then the type 2 error, which is the beta, shows to fail to reject the null hypothesis when it is false. So now that we have quickly summarized the concept of inferential statistics, we would quickly go into calculating using t-test. For this sample, we'll be basing our tools on t-test and ANOVA. So we'll quickly go into our data sets. We'll be calculating the t-test for age and price. This table right here has extracted our sample data for age and price. Okay, so we will be performing a t-test, which at the end of the day should look something like this table. And also we'll be performing an ANOVA for gender. To perform an ANOVA for gender, because ANOVA is used for 2 or more groups, we have splitted our samples for female, male, and firms, making sure that they are equal numbers, just as we have understood in our introduction. And then we'll perform an ANOVA, and at the end of the day, we should be having a table like so. All right, so quickly, let's dive into how to go about this in our next class.